Hello everyone, this is Koda Singh and this is the fourth tutorial in the NumPy series. So we will be talking about built-in NumPy array methods. So these are the methods to create NumPy arrays, also called metrics. If you must have read about matrices and determinants in your 12th standard. If not, it is basically square boxes which we see over here. This is a matrix. It's a 2 by 2 matrix. So that was something I was talking about. So let's talk about the built-in methods. And again, if you want to have the access to the notes, the link will be in the description. You can use the notes in whatever way you want. You can use them for any purpose. So let's start without any further ado. So np.zeros is the first method. It's a built-in method. Create a matrix of all zeros. So let's see how it is in the action. So I'll do a is equal to np dot zeros. I hope my np is already imported. If not, we have to import it again. Let's see. Okay, np is not defined. So what I'm gonna do? I'm gonna do import numpy as np, or I'll just run the first command over there. So I don't want to create a mess because I want to give the notebook also. The notebook link will be in the description. NP0. So if I go A, so as you can see, I get a matrix of 2 by 3. So 2 rows and 3 columns. These are 2 rows and these are 3 columns, 1, 2, 3. Anyway, if I want to go for the ones, so let's see what we have. So np.ones, so it will create a matrix of all ones. So let's see what is it. B is equals to np.ones. Let's go for 2 by 2. Oh, I went for 2 by 3. Let's change it 2 by 2 B, and here it is 2 by 2 matrix of ones, all ones. So we have some note over here. By default, the data type of the values created by built-in functions np.zeros and np.ones is float 64. We can change it by specifying the data type. So I told you in the last tutorial that how we can change the data type. So a.d type will get the float 64, b.d type we get the float 64. Let's suppose I want to create a variable of np.zeros, maybe. Yeah, np.zeros. Go for 2 by 5, and now I want the data type to be int 8 so that I can save some memory, as I told you before also. So I go see, now you can see it's all 0. Before it was 0 dot, it was float. So anyway, if I check c dot d type, I'll get int 8. So what's the use of using data type? We are just saving memory, so we can load a lot of data instead of doing batch processing. We can have more data in that particular batch. So anyway, let's go further. So np full, let's suppose now you want an array of a particular number. So it's about that thing. Apart from 0 and 1, you can go for 0 and 1 as well. So d is equals to np full. So how you're gonna do it? You're gonna specify a number over here, the shape, and then the number. So let's suppose over here I want a 3 by 3 matrix of number 10. I print out d and I get 3 by 3 matrix of 10. And let's see what is we have np.full like. So it is basically if you already have a matrix of some shape. Let's suppose you have an image of 256 by 256. So you are not you're not able to get the shape out of it. So you can just directly say that, let's suppose in this one I can say e is equals to np.full like I want a similar shape of d. I don't know what is the shape of d, and I don't even want to know. So I can just say normally pass d, and I can pass the value. So I'm gonna get e, which will be of 30, but the shape of these two will be same. So if I want to get the shape of d, it's 3 3. If I want to get the shape of e, it's 3 3 again. So the next one is np.random.rand. So now if I want to create a matrix of random numbers, how will I do? So I'll go f is equals to np.random.rand 2 by 3, and f. So as you can see, these all are random numbers. If I go again, you can see the number changed. So the thing with it is it only gives the number which is between 0 and 1. So what if I want to have number between something? So let's talk about np.random random sample. It is same as np.random.rand, but in it we can pass the shape of already created np array. So it is same as the previous one, like like the previous thing. So a dot shape we can do, and we will get the we'll get a random digits, random sample, random data. But it is kind of not important. Like it's same as the upper one, but this one is important. np.random.randint. So what if I want to create a matrix of integers? So I do randint, and then I pass in the limit, the upper limit till what it can come, and the size of that particular thing. Let's see it in action. G is equal to np dot random dot rand int. So I have to pass the upper limit, like till 10 I can get the numbers. I want to pass the size is equals to 2 by 3. As you, the thing which came, the pop-up which came, I used tab to get it. So it gave me a suggestion that size is the suggestion, like size is the data. As you can see, the upper limit is 10 only. Like the numbers can come till 10, till basically till 10, like in the sense 9 is included but 10 is not included. So let's see. So you can see the 9 is the uppermost limit, but you will never see 10. If you want to see 10, then you go for 11 and you might get to see 10 also. So you got 10 over here. This is the upper limit, so it's not included. uh, so np.repeat, it will repeat a copy of array the number of times we will tell to create. So it's very handy at times when you want to repeat something, like you know that you want 1 2 3. So let's suppose I create a test 1. So I do np dot array 1 2 3 1 2 3. Now I want this particular array to be called again and again, so I'll do np dot repeat. I'll do np dot repeat, and I'm gonna pass this array. I'm gonna pass the number of times. So how many times it's gonna repeat. So as you can see, it repeated. So 1 1 2 2 3 3 3. But now, what if I wanna repeat it in the horizontal order, like uh, in the sense that it should come one above the other. So I'll do axis is equals to 0. So as you can see, it came 1 2 3 1 2 3 1 2 3. If I do x is equals to 1, it will be similar to that previous one. So you got my point, I hope. And I don't think so we need this particular thing over here. Yeah, so this is very important. If we go for this one, then the axis upper limit is 1, but if I remove that thing, the axis upper limit is 0. So I hope you got my point over there. And that was something I wanted to show, because I got that error too, and I forgot kind of how to generate that particular error. So copy is very very important. It was very difficult for me initially, when I was doing NPRA, when I was playing with the machine learning and everything, that I was not able to copy data. So you can say, why are you not able to copy data? Let's suppose I create a matrix of I already have h, I guess. Yeah, I do have h. Let's not go for h. Let's create a new one. A is equals to np dot array 1 2 3, and now I do b is equals to a. So I print a first, then I print b first, but now I do b 0 is equals to 20. I get b is equals to 20, but a comes out to be 20, because over here it is being copied by reference instead of being copied by value. So if I would have done c is equals to a dot copy, and now I want to print out c. I want to change the value of c 1 from 2 to 40. I'll print out c over here. I get 40. I print out a over here, which I just copied it. So let's see what's the value. So over here I get 20. I got 2 only. So this is the if you don't use copy, then it's gonna be copy by reference, and it's gonna make a lot of problem in your if you when you will be calculating stuff and doing other things, which I'll be teaching you in the next tutorial about the calculations and everything. So just make sure you copy it in the it got copied into the reference. So you guys can skip this video and go to the next tutorial. Those who don't know what is by copy in the reference, I'll tell you. So you created a variable a. So once you created a variable a, it is stored in some memory over here, and when you copy it without the copy function, so if you copy it without the copy function, then the same thing points to this particular thing. This a is also pointing to that particular thing, and that is also pointing to the same particular thing. So once you do any operation to it, this particular address is being affected. But when you copy, so the c variable which you copied, it created a new reference in the memory in the sense RAM. It was holding new reference in the memory. So these two became independent. I'm sorry for the handwriting, but I thought I think so you guys must have got it. So these two become independent, so I can do any operations in it. So thank you so much guys for watching the tutorial. I hope you understood what is copy by reference and copy by value. I hope I was able to make you understand, but it was not a more of memory management thing, but still I thought I would rather explain you guys. So thank you so much guys. If you like the video, please do like it, subscribe my channel, comment. It really motivates me to make content for you guys, and see you in next tutorial. Thank you so much guys.